Hello everyone, February 17th. Alright, let's do this. Construct smallest number from di string. Di string. You're given a zero index string pattern of length n, consisting of the characters I, meaning increase, and d meaning decrease. Okay. A zero index string num of length n plus 1 is created using the following conditions. Num consists of the digits 1 to 9, where each digit is used as most once. If pattern I is equal to I, then nums I must be smaller than nums I plus 1, otherwise be larger. Return the smallest possible string num. Okay. So I have example I, D, D, D. So if it's I, right? So this is 0, 1, 2, 3, 4, 5, 6, 7. So we have 8 in total. So we need a 9. Which means this has to be smaller than this. So I can make the smallest to be 1, 2, 3. Oh, I cannot do 1, 2, 3. Oh, like this. I mean, I can do 1, 2, 3, but this D, that means this has to be larger than this, right? That's larger. So I cannot use 1, 2, 3 anymore. So this has to be larger than the next one. So if I use 4, then I don't have anything. Okay, that has larger than this, it must be smaller than. So if I do 4, then it doesn't work, right? Because this must be larger than this. Yeah, I can say I can do 4. Then I try to this one. And it has to be smaller. Then I would say 3, 2, 1. No, 4 says 4 cannot work. So the smallest has to be 5. As 5 here is only be 4. And this must be bigger than 4. For 5 I have used, so I have to be 6, 7, 8. That is not correct because this has to go down. My bad. So again, like I can try 6, right? And then next has to be smaller than 6. I cannot do. So this has to be 7. So smaller than 7, I have 6. Smaller than 6, I cannot do. So it has to be 8. And then I do 7 here. And then there's 6. Where are 9? Oh, n plus 1, because D has to be larger than the next one. So I have one more position to fill. So this is not right. Oh my god. My bad. So now I have to go with 9, 8, 7, 6. Okay. I mean, we can backtrack again. We can backtrack again. We just try it because it's basically the same solution. I wonder if there's a better way to do this instead of backtracking. Backtracking basically means we'll go through all possible scenarios, right? Let me think. Yeah, so each time we'll try the smallest so far, and then we'll see if it works. If it doesn't work, we'll increase. If it doesn't work, we'll increase. Right? That's basically how we're gonna do. We try the smallest first. Yeah, let's just just try this. I feel like this probably is going to work. So it's like a backtracking feast. Of course, we're not going to use that. Of course, we're going to use as a vector int. No. Yes. Vector int. And we're going to say, call it array of size, right? N plus 1. And we start with 0. That's perfect. And then we have also vector. Ooh, I can actually go through. I can go through array to see what's. I think it'll be easier if we get another one. Boolean scene. Right? So I need the same length. And then we can do backtrack. Void. Alright. When you backtrack, what do you need? I need the position. Like at this position, what should we do? Right? So I can say I need an index. Of course, I need the array. And I need the scene. Pretty much that's it, right? So yeah, essentially we keep going, and if we hit the end, that means we have done. We have succeeded, right? Therefore, I think this is still Boolean. So if index is equal to array.size, should return true, right? And if scene, no, not scene. If array index is larger than 0, then this position has already been set, so I need to go for the next one. So return backtrack index plus 1 array and scene. Alright, now the current position is empty, right? Then we need to go through the scene, try, so for int v value equal to 1, v smaller equal to 9, v plus plus. Ooh, 1 to 9. Does not have to be 1 to 9. I think it's just array.size. Array.size. These are the, because at most, wait, hold a second. We use them at most once, right? So we definitely try to use something smaller. And we do the pattern. Like if pattern is this, right? So we say it's gonna be 4. Ooh, 4. That's actually not right. So we have the size, right? So the size is 3. I need a 4 to get 3. So actually, I think this has to be plus 2, right? That's the total number that we can get. That's the total number we can get. And this is what we need to put in there, right? We need to put 4 number in there. And this is we need a 5 because I need a 1, 2, 3, 4, right? Therefore, index corresponds to the array, which is perfectly fine, right? This index is done. So basically you're setting yourself, and I go to the next one. The next one to compare to the previous one. Right? Next one to compare to the previous one. So here is not this. This shall be seen dot size. Right? This is the current. Let's call it current. Call it C. Right, we'll call it C. Alright. So it's from small to large. I say if not seen, right? If this one has not been seen before. If it has been seen, then we just keep going, keep going, keep going. If it has not been seen before, then we can try it, right? Well, if this and it depends, right? Depend on, because we current is at this position, and we need to so if the last one is I, oh, we need to check -1. Hold on. All right, I'm back. So basically the current is depending on the previous one, right? So the previous one, if it's not seen, and I is equal to 0, or I is not equal to 0. Right, so either I equal to 0. If I is equal to 0, I don't have a previous one, so anything will do. And if I is not equal to 0, then what I want is, that's actually there's a lot of conditions. Or something, right? So it depends on the pattern. Well, we need to pass the pattern as well. I call it pat. Okay, so I need a pat index, right? -1. If index -1 is equal to I, then we do something. Oh, I realized this has to be another parentheses here. It's basically and something or something, right? So this, so if it's I, then me C must be larger, right? It must be larger because it's this condition. Next one must be larger than the previous one. It must be larger than array previous one, array the previous one, right? Or we say pattern index -1 is equal to D and C must smaller than array index -1. Right, so these are the conditions. If these are satisfied, there's no I. Index. If these all satisfy, then oh no. This or this. I think I need another one, right? If these all satisfy, then I can say scene C equal to true and array index equal to C. And then we say if backtrack index +1 or index +1 pattern array scene is true, then we'll return true. Otherwise, this is what we'll backtrack. Scene C will equal to false and array index will equal to 0. Right, we'll get back to 0. And we try the next one, and then we try the next one. And at the end, if nothing works, then that's when we'll return false. And here, I'm gonna call backtrack. We'll start from 0, right? And pattern is just pattern. Array is array and scene is thing. So once we're done, we just need to create the string, right? Can I just do, all right, I don't know, string from vector of int. String stream. Copy in conjunction with string stream and O stream iterator. I think I'll just do this. Maybe I'll just do add plus. And say string res, right? Std string res. I think I just do that, and I can say for int a in array. I say res plus equal to, I don't know, integer to string. Int to string. I'll just do to string. Std to string a to res. Two 375. Backtracking again. I think it's O(n) factorial again. In fact, I think it might actually be n times this, because you have to go through everything. I mean, if you think about it, right? The first position you can have all different ways. The second position you can have all different ways. The third position, yeah, it is O(n) factorial. Let's go O(n) factorial. Alright, let's just run this. Yeah, I think it will work. Yeah, that works. Bit masking. Oh, it's n plus 1 factorial. That's why it's this. So times n again. Okay, yeah, makes sense. So it's not right. It should be n squared. Yeah. That is true, but I feel like this is faster than that. I do go through every single one at each recursion. I do go through that, and yeah, it's all right. So optimize with bit masking. 9 to the n. Regulate brute force via recursion. O(n). What? Ho, 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 ho. Using stack. Oh. Greedy with sliding window reversal. Optimize greedy approach with pre-computed desegment. All right, I think deserves some more reading. I'm happy with this. I'll leave it here. Bit masking. Okay, what the hell is this bit masking? Hmm. Okay, so basically in our solution we don't have to use this. Yeah, I didn't realize. We can use bit masking. True. And then what? Find smallest. That's the recursion. Pattern. Current position. Used. Current num. Current num. What is current num? Oh, you're building the num along the way. Ah, I see. Okay. Ah, that's another improvement. Yes. I mean, I'm using the vector, but you don't have to use vector because you can build a number along the way, just times 10 and plus. Exactly. Okay. Yep, that is an improvement. Bit mask and then this. I feel like this might be exactly the same way I'm doing it. Right? Return this basically the end, and this is the result. This is the last digit. Very smart. Should increment if current is 0. Yes. Well, increment uh, or the previous pattern is equal to I, then you should increment. Okay. Otherwise, you don't. Mm-hmm. And that I simplify this part. Try all possible that are not yet used. Oh man, that is my solution, which means I got it wrong. So this is whether it's used, right? It's not used, and current is larger than last digit. It's equal to should increment. Nice. If it does, then result equal to it use result equal to min. Okay, yeah, that's exactly the same as mine, which means I got this one wrong. 9 to the n. At each step, it tries all 9, which is n, which is 9, and recursively check if they fit. Recursion depth is n plus 1. Exponential number of... I don't know. Because the recursive call, it's really not 9 times 9. But n factorial is not right. Yeah, I realized that. N factorial is not right. It should be 9 to the n. Well, it should be 9 factorial, I think. Well, but each step you have to go through them. Yeah, each time you have to go through 9 times, right? It basically just said at each position you can have 9 different options. The next position you have 9 different options. It's 9 factorial. And it's actually not 9 factorial, it's n factorial. I think it's n factorial, but this is exactly the same. It's just smarter, right? Bit mask and direct computation, that's, yeah. So we can skip that one. All right, what is this? Regulated brute force via recursion. Sounds very, very interesting. Okay, I just read the code. So we build a sequence, we reverse it, and obtain a result. Start building a sequence by calling the helper function. Okay. Build, return int. Oh, reverse. Oh, result. Okay. So we build it. We have the current index, current count. We have the pattern, and then we have the result. Current count. If current index is not equal to pattern dot size, which means it's okay. Now we say if the current pattern is equal to I, increment the count and then move to the next index. Increment the count and move to the next index. Increment the count. What the hell is the count? This should be current count, right? Yeah, we can submit a ticket. I think it should be current count plus 1. But hold a second. We will increment the count and then move to the next. Else, if D, keep the count and move to the next. And the result will equal to current count plus 1. Ooh, what the hell? I don't understand. How the digits must be arranged based on a given pattern. When we see an I, the number should be in increasing order, which is straightforward to handle. However, when we encounter D, the number should be in decreasing order, which introduces complexity. That's true. If the pattern consists of I, then the solution is simple. Yes. However, if we introduce D, we must be more careful. A D means that the current number must be larger than the next one, and we can't just keep adding numbers sequentially. The challenge is that when we see a D, we don't immediately know how many consecutive D characters will follow. So basically, if we have a D, and the next one is it's not really next one. It's just the distance between the first D and the next D will determine, because in between, right, we have a D, okay, and we have another D, and in between is all I. We don't know how many I there are, and these must be increasing, right? And this D must be the last I plus 1. So what we do is we go. Like if we have a bunch of I at before, but it doesn't matter. At this position, we will know what could be here if it's an I, right? In this case, it shall be a 4, right? We say we know it shall be a 4, but since it's a D, then it cannot be 4. So what we need to do is go find the next D, right? We find the next D, and then what we know is this must be 4, 5, 6, right? And then we can fill these, and this D must be this 1 plus 1. That is an interesting idea, right? Man, I am not going to recurse this. I think what we can do is, and what if you have multiple D's? You have D, 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 and some I's, and then you have another D. It's the same thing. Whatever this one needs to be, right? Whatever this one needs to be, it will go here. It will go here. And then we'll increase, and the last one plus 1 will come here. The last one plus 1 will come here. And then we plus 2 come here, plus 3 comes here. See, that is very interesting. I think we can code this. Basically, we scan the whole thing. Oh, that might be the stack solution, honestly. That might be the stack solution. Because if it's I can say we don't even push, right? If it's I, we immediately get the result. Get a result. If it's a D, I push into the stack, D push into the stack, D push into the stack. And if it's an I'll continue the number and I'll hit another D. Index. If the 2D does not have another I in between, I just keep pushing it into the stack. If they have a gap, then I can stop popping. All right, I pop this. This has to be, this seems to be a very, very good solution. Hold on. Let's try it. Oh, without actually reading how the stack works, but I think we know. That is a good observation, right? So this solution is inspired by the editorial. Notice that when we have consecutive i's, we simply increment the digit, right? When we have D, we cannot immediately decide what digit to assign it, because its value is dependent on the number of wait, hold on, is that right? No, hold on, I don't think that's right. What if hold on. I, right? 1, 2, 3. I have a D and I have a I. In that case, I cannot say that's 4, 5, 6. Then it just becomes 7. That's not right because I can do 5, 4, and 6 and 7. Right? I just need, because it's 1D, right? And then I cannot fulfill this one. I need to go to the next one. But since there's only one, I do a once, then I can already come back. Right? I can already come back. 5. So if I have 3, say D, 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 I. Do that. Okay? So 1, 2, 3, can do, cannot do, cannot do. That's 3, right? And I have, say, this will be 4. But I cannot go back because I need to have 3 things here. Because this has to be larger than this, has larger, this is larger than this. So 4, I think this is larger than this will be 5, 6, 7, 8. I cannot do that. 8 has to be smaller, so this will be 9. Is that right for this? I, D, 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 I. Wait, what? Oh, I didn't. It's just to return this. Yeah. So hold on. So basically, you're saying I just need to fill this one, right? I fill 1, and then I can go through this whole thing. And if it's D, 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 I push them in, and then the last one has to be 1 and 2, 3, 4. So I just do 1. I just look for this, and then I can just go back up, right? And then I keep going. So, we cannot immediately decide if we have consecutive, right? Consecutive these, we cannot immediately decide what digit to assign the first D, because it is dependent on the second D, so on and so on. So in this case, we keep moving forward, right, until we hit the first I. Then we hit the next I. This I, we have a deterministic value, which is the smallest so far. And after filling this I, we can fill the previous D's. We can use stack to do this, but we don't need to physically have a stack. 2 pointers shall suffice. Yeah, I'm going to try two pointers. So we have this move, right? And each time we move, we'll do. So I'll say std vector int array. It's gonna be pattern dot size plus 1. Okay. And then I have 2 pointers on a pattern. And now we start move. While we have a D, we record which position it is. Now we go to the next one, we go to the next one, and boom, right? We hit another I. So when we hit an I, we check the previous, right? If the previous is still I, then just gonna be digit plus plus. If the previous is D, then we just go back to fill all those D's until we hit the last one. So we can say D is digits should be start with 1, and for int I 0, I smaller than. I don't like this, but it's fine. I smaller than pattern dot size I plus plus. Okay. So we say if pattern I is equal to I, if I is equal to 0, or pattern I is equal to pattern I is equal to I, and pattern I minus 1 is equal to I as well. So when this happens, we simply say we will assign array I shall equal to digit and then digit plus plus, right? Else, basically, pattern I is, hold a second, this this is actually not right. Because if it's a D, I don't really consider, so I'll do it later. Right, so if that is the case, then we say if the previous one, okay, let's do this. If I is equal to 0, okay, array I equal to digit plus plus, okay, else if pattern I is equal to I, okay, if pattern I is equal to I, and if pattern I is equal to D, we basically don't do anything, right? If it's a D, we don't really care. But if it's I, then we shall say if pattern I minus 1 is also an I, then in that case, we're gonna say array I equal to digit plus plus, else, which means the previous is a D, then for each of these D's, then we should say while yes, so we say int j for int j equal to I minus 1, j large equal to 0, and pattern j is equal to D, j minus minus, and so for each one of those, we'll say array j equal to digit plus plus, right? So this will add digit and plus plus, and then we'll go to the next one, digit plus plus, and the next one. Okay, so once we're done, we fill all of them, then we go out, that I will move on, and then at the end, I don't even need to do this way, right? I can just say int num equal to 0. Okay, here this is gonna be interesting. Right, this is gonna be interesting. So instead of doing this, I'll say num plus equal to num times 10 plus digit plus plus. Right? Oh, I cannot do it because I have to backfill. My bad. Yeah, that's fine. I have to backfill. Okay, and then at the end we'll say array dot size minus 1 will equal to digit, because that's the last one, right? You go for the last one. What if we end at D? Now that is very interesting. If we end at D, if we end at I, like the last one is I, then we'll have this blah blah blah, and then the last one will be just digit. But if we end at D, basically we just skip, then the last one, right? Then the last one, and yeah, this is correct. This is the last one, right? We said the last one should be the digit, but we need to check if the last pattern is I, then we're good. If the last pattern is a D, then we need to do this one more time. This piece. Right. So this shall be array dot shall be pattern dot size -1, which is the last one. If it's equal to D, then we'll do this. But if it's not equal, if the last one's not equal to D, then we don't do it. Okay. Then what we're gonna say is std string res for int array of this res plus equal to std to string a, and now return res. All right, let's try this. This, if it works, will be very interesting. Okay, it does not work. Oh, why does it not work? We didn't handle DDD. Ooh, the last one has issue. Wait, hold on. Why? Oh, my bad. My bad. I got it wrong. Hold on. Yeah, this is my mistake. It is my mistake. If this is equal to I, and I say here is if I is equal to 0, or the previous one is also equal to I, that's when we do this. Okay, so change it a little bit. Change it just a little bit. Okay, still not right. Oh, this has to be plus plus. Okay, this one's good, but the other one is absolutely shite. A 0? What the hell? A 0. Okay, that is not what I want. Hold on, I go 1, 2, 3, skip. That should be 4. Hold a sec. So I start with this, right? So yeah, so I got 1, 2, 3 is correct. And then we got this, then we skip. I have next one is I, right? Next one is I. And oh, I see. I shall do this one here. Because no matter what, I'll set it. And I say if I is larger than 0 and this is equal to D. No, I don't have to do this. All I need to do is just go directly do this. Dude, just do this, right? I get the current is I always assign it, and then I check the previous, right? I check the previous. If there is any D, I will assign those D's as well. Now, I'm pretty sure if I add one pattern to, like we add an I towards the end, that can make things easier, right? Yeah. Yeah, hold on. Let's do this. Let's say std string new pattern is equal to pattern plus I, right? Then I just use new pattern, and it's all new pattern, new pat. Then I don't have to do any of these, shall be handled automatically. There we go. Look at that. Look at that. Let me format the code a little bit. Yep, this is it. This is the ON solution. I want to test one more thing, and probably test something like that. All right, so let's throw a few more test cases to it. Let's see if it works. Yep, I think this is it. This is probably the, yeah, this is probably the greedy stack. I don't know. We didn't use stack. It's probably the greedy. Greedy was sliding window. I don't know if it's sliding window, but we basically, we go forward and then we go backwards. I didn't see any backwards movement here though. And you reverse. Oh, you reverse. Oh, that's pretty nice. Yes. I mean, it's the same idea, but you reverse. The same thing, right? You go, go, go. You basically just keep going. 4, 5, 6, 7. And you find the first time that there's a D, so you just reverse the whole thing. And then you keep moving on. Yep. That's the same idea. Same idea. Pre-computed D segment. That doesn't matter. We already find the ON. Okay, that will be it. Was good, right? It's a good problem. We start from what I think still the ON factorial, the brute force back what's it called? Backtracking, right? We start from the backtracking, which, you know, yeah, it works, and didn't really put too much thought into it. But then as I was reading through the editorial, yeah, it just occurred to me that there is a pattern that we can leverage, and this is how we leverage it. Yeah, and then you can also build a string along the way, and then you can do a reversal. That's actually pretty neat. Okay, that will be it. I will see you guys tomorrow. Adios.